How is everybody doing?
Feels great to be doing stuff.
Yeah, feels great to be doing stuff. So, not a lot has changed since we were online earlier. I made a couple of small changes, but right now what we're going to do is we're just going to replace this whole method by just deleting it. This thing only gets the line number, so I don't really want to name it the PGN importer. I just want it to be a thing that gets indexes. So we're going to change this around a bit. Instead of being a PGN importer, it's going to be a PGN game finder. And that's game finder. We'll change our test case in a little bit here. And this is going to be find games. We will just we're gonna grab this and use that in a little bit. Go. Okay. Now in here, we'll make a method for, oh, why is my, gotta move my mic here. It's not where I want it. There we go. There we go. Okay, so this is now gonna be, private buffered input stream get input stream string path. Okay, return that. That seems fine for a test case at least. And we will do get input stream. Perfect. And what's unhandled? Yeah, we can just throw it. Same thing with all these. Oh, that's not what I wanted. What did I don't think I wanted to do that. Did it create a method in here? Yeah, it did. What did we want to name? This is find games. That's right. This becomes find games. There we go. And then this is going to be get input stream. There we go. Okay. Get input stream. Okay, and then we'll, when we're done here, what's this? What have I done? Oh, there we go. We're gonna run our test cases again after we do this. Make sure that we didn't wreck anything. Find games. Get input stream. Okay, so go find games, get input stream. Figure out how to navigate to the end of words easier. We will learn this stuff. We're doing it in baby steps. Find games, get input stream. Okay. Let's run these tests. What did I do? Do these not run? What? those... I know it doesn't like this. New buffered input stream, new file. Go. And then this is going to throw, no? Change buffered input stream to compatible type. The constructor file is undefined. What? What did I do? What did I do over here? I thought I just did the same thing. Maybe I was just going too quick. Let's stop. Let's check here. Uh-oh, that's not what I wanted. Hold on. Resize. Ah, now everything popped up. Okay, hold on. I have a button for resizing my windows. It's cool. File input stream is not a file. Okay, fair enough. File input stream. There we go. Done. Okay, now can I run these tests? Okay, they run fine. Got it. Good, good, good. Okay. So next, we're going to take these and do something else with them. So now we've got, so we got a game importer. Okay, now we've found the games. Do we hand in, is this going to be a buffered? I think so. I think this is going to be a buffered input stream. I think we're just going to use the same one the whole time. That. Okay. That's fine. This is a game importer. And this should be a PGN importer? Oops. Hold on. Gotta give that a Java. Let's do that again, because I think if I do that again, that'll just generate more stuff. There we go. PGN importer. Implements game importer. Okay. So let's implement our methods here. And I think, hey CodeFox, how's it going? I think what we're going to want to do here is this is kind of where, is this where we set up the buffers? No, I don't know. We'll start with just this. So just this. We're going to need the path, so... Or no, we won't, because they're going to pass in the buffered input stream, so we don't need that. All we really need then is the game finder. Oh, you can go away that side of the screen. I don't need you anymore. We'll refine this as we go too. And for now, we just throw everything. We can come back and clean this up. Sure, we can update the... We're nowhere near ready, so let's just add that to there. And again, we'll come back and clean this up. First, we got to get just a little bit closer to something that actually works. Right, and we got to return a chess game at the end of this. So right now, we will just return null until we get there. So that gets us to a point now where we have a list of game bounds. Okay. Game bounds. So the game bounds are the exact bytes on which these games start and end. So now that we've got that, we need to find an efficient way. I guess we got to reset that buffered input stream. That's what we really have to do. Which is probably a system arrays copy. I can't imagine looping through that's quicker. That doesn't seem right. We can try both and see what happens. But okay. So let me just refer back to here. What did we say? We didn't say much. We said maybe using a blocking queue and then parsing. So right now we're kind of here. It's how do we want to signal there are more games or less games, and how are we going to handle the multi-threading of parsing the games? So that might be a small tinge of research to see how we want to handle that. So let's see what we have access to here. I'm just trying to find the good documentation so we can look at it. I think we're looking for executor service. Let's take a look at that. Hold on chat. I'll be right with you. Okay. So all known sub interface. Executor service. Okay. Let's see. Manages the termination and methods. Wait, sorry. Provides methods that manage termination and methods that can produce a future for tracking progress of one or more async tasks. Okay, we can. I think this is more or less what we want here. Executor has no tasks actively executing. No tasks awaiting and no new tasks can be submitted. An unused executor server should be shut down to allow resource reclamation. Submit a method by creating and returning a future that can be used. Okay, to cancel execution. Fair enough. So fixed thread pool size. Okay. So I guess this is kind of where we're going to set this up. So in here, game importer, no, PGN importer, there we go. So right here is kind of where we're going to do a lot of that. Because realistically, we don't want to hold any of this in memory. We want to offload it to the database like as quick as we can. So I don't really want to be in a situation where the futures come back and pile up. Does it say if an executor service is physical threads or virtual threads or both? That's a question I have. Does an executor service use real, virtual, or both for threads? So, okay, you can pick. Okay, so I need both. I need two different sets of things. So what I really need, what we really need to continue here then, let's come back over to our crap drawing. What we really need is executor service, real threads, okay, new thread, okay, deserialize PGN, and then, and can I do like a, let's see, it's done, error, completable future, sync hello, callback receipt. Okay, cool. So we can do callbacks and automatically kind of do some stuff here. So what we can do here is an executor service kicks off a new thread that deserializes the PGN. And then on the callback, so when it's done, how are we gonna, we'll do it this way. So we'll show the callback like this, just because that's how I feel like it. So boop. The callback here is add to, we'll say a blocking queue for now. I don't know what it'll be, but we'll say a blocking queue. And that blocking queue, there's going to be another set down here of executor service with virtual threads. Virtual threads. Okay. And that is going to batch insert to Postgres. So that's kind of what we're looking at. An executor service starts a new thread that deserializes a PNG, and then those are going to queue up in a queue until there's 1,000 of them, and then when there's 1,000, an executor service is going to pull 1,000 from the queue and insert them to Postgres. We can tweak the numbers of how many we're going to wait for and what we're going to do with them later, but for now we'll just stick with 1,000 and see what happens, because we don't have a Postgres database yet either. These are all tweakable numbers. We'll probably put them in a settings anyway. So let's start looking at how we can do this. Once we get to the PGN importer and we've got our list of game bounds, then I think we can start up a parser. So I guess maybe let's start writing something that can parse one game. New file. No. New folder. Parser. So now PGN parser. Wait, hold on. I keep forgetting I have a actual thing for that. PGN parser. Okay. So the PGN parser is going to take in a byte array input stream? I think. PGN parser byte array input stream. No, that's not a byte array input stream. Byte array input stream. Okay. So what are my reading options here? Is it the same as like a buffered input stream? I think so. I can skip too. That's really nice. Okay. Okay then. So now comes the question of when, or do we ever, because maybe no, do we ever start looking at these as strings, or do we only care when it's a byte array input stream? Okay, so can I do fractions of x bytes? Okay, so can I do that? No. So how do I, let's see, do we got to read one by one like we did for the, okay. Read from a byte array input stream 1 byte at a time. Okay. So we can do it this way instead. While, and we're not going to keep declaring byte b, and we're going to say b equals dot read not equal -1. And I know I need brackets around the read part. I don't know, this should be int. Okay, there's got to be a better way than that. That's dumb. That's dumb. Let's do, I kind of want to do it more like this. We don't want to... How many bytes should we read at a time? Let's look at a game. One game with tags. A line can only be 255 bytes long, which is a lot longer than this. And this whole game, without any commentary, is less than 1,000 bytes. So how... I double... Yeah. So... This is just bytes read. I think. What does read do? Reads the next byte of data. So if that is a byte, why can't I do this? Oh, right. So how did I... Oh, okay, because when you do that, you kind of automatically get that. It's because you're passing in that as a parameter. It calls the other one that does that. Okay, that's why. So if I did that, other than I can't reference that. That's so. We did current byte equals new byte 1. Okay, and then okay. This is bytes read. Okay. I don't think we need to know this, though. I think I can just do... and then say... No, that won't work. Okay, okay, so this should be fine. I don't think I ever need to know what byte I'm on like I did previously. I do want to try something though. Can I do this and then just put this here? You won't assign that, will you? Okay, And what does this read do? Reads the next byte of this input stream. So if we did what does this return then? Is that returns an int? So how do I... Well, that's fine. That's fine. We'll go back to this. Sure. Can I just get next though? Like, I don't really want to do that if I don't have to. I want to get the next one. So, okay, sure. Or should we be switching to char? I don't think we ever need to really worry about char. A lot of looking stuff up. It's been a while since I've had to use a byte array input stream. I guess we kind of do need to know a little bit. So let's... Can I figure out how big the average PGN file? How big in kilobytes is the average PGN file? A single game is usually 2 to 10 kilobytes. Okay, so let's do 2K at a time. I'll change this to buffer. And then we'll say, where did I put that in here? Because I want to kind of stay similar to what I did in here. Did I put it in the loop? No, I declared it outside the loop. Bytes and buffer is outside, and then we just set it. So we'll do the same thing here. We'll do bytes int bytes in buffer. Bytes in buffer equals that. Okay. We kind of got the same thing going on here. That's our 2 kilobyte buffer. What did I do in here? I don't even know. Okay. So once I get this byte array input stream, then we're going to loop over it. We're going to say for int I equals 0, I is less than bytes in buffer. Okay. I don't need my total count anymore. I do need my current byte, because I don't think I want to hit that array over and over again. So we will do a single byte for current byte. And we'll say byte equals buffer I. That's all fine. Oh yeah, we're gonna need game current byte equals that. Now we start parsing. We know we've got 2K. So first thing we need to do is look for tags. So we're kind of going to have, these may end up being constants. Let's make a let's say bgn constants. We'll use the actual context menu insert there. bgn constants. And we will come back and clean up. We'll come clean this one up later. For now, we're just going to do this. And we will do a find replace on this and say private public boop. What? Oh, there we go. Boop. Done. Okay. So now we'll just use those instead. We'll fix this one up later. Okay, so we're going to say if the current byte equals bgn constant open tag or current byte equals bgn constants dot turn. Actually, we should do these different. We should do these different. So if, oh god, let's go back to the spec. Can they use the same friggin' brackets in the game notation that they can? Let me see. Port format, standard notation, basics and disambiguation. Okay. Got glyphs and symbols. Where do they add comments? Let me just look for 37 matches. This is for tokens. Okay. Okay, so the good news is I think that it's syntactically invalid to put these anywhere else, which is great. Where? I don't even see that one. There we go. Good. Oh, the formal syntax, we found it. This is going to help a lot. Tag section, move section. Tag section is tag pair. Empty section. Tag name, tag value. Tag name is an identifier. Tag value is a string. Okay, so that's good. That's really good. That makes this easier. So if the current byte is that, then we have to be processing a tag. So now in tag. Okay. So now we can say in tag is true. We should probably do this first. So if in tag not equal true, and the current byte is an open tag, then we're going to do that. Okay. We might have to do a switch statement on the constants to be quick at this. That might be better, because this is going to get big fast. Current byte. We'll start with just a break. So if I find an open, then I need to set in tag equals true. And if I find constants dot, we're going to have to add a new one. Okay, that didn't work. Undo. This is going to be a close tag. Okay. Refactor this, close open tag pair, because that's what they're called. Change this to close tag pair. Back over here. Close tag pair. And tag equals false. Okay. So if that's true, okay, then I think what we need a default. Well, and in the default for this, so this is going to have to be okay. We're also how A lot of thinking here. I should just start testing instead of thinking, but I like to think these through a little bit. So if the current byte is an open pair, set that to true, and then that's really all I can do this iteration. So I guess I really need to know if I'm in the tag section or not. So I've got it. Am I in the tag? And then no, I don't like that. I don't let's take a different approach. Let's say we find an open pair. Why can't we do something like this? So let's make I'll comment that out for a sec here. Let's do a map of, did I make an enum for that? I don't remember. I did, but I can't get at it. So for now, we're just going to do string. Tag pairs. Use new array list. Or no, hash map, sorry. Okay, what do we do? Add a couple imports there. So what if when we get here, we said process tag, and oops, that was down here. We process tag. We're going to have to pass it the index, so int I. And I think the label, if I go back to my documentation, I think I'm not even going to say, I don't know. Let me go check the tags here. A left bracket token, a symbol token, a string token, and a right bracket token. Are there any tags that are more than one word, meaning that they have a space in them? I don't think so. No, they don't. They use camel casing. So we can say string label, string value, and then we can say, so when we get to here, we know that. So we can say I++ to get us over the bracket. And then we can say start, let's say -1 int n equals minus, and then we can say here start equals I, and then while. We're gonna clean this up. I want to get something going. Keep going equals true. So while keep going And then we'll say if buffer I equals a space, then end equals I minus 1. See, this looks okay until you realize that you're only processing 2 kilobytes at a time. And that you could be on a boundary. So I don't think I can just go with a route like this. Like, even though this is like, we could clean this up, we could make it better. It's not great right now, but even if we made that better, I don't really like it because you can end up in the middle of the buffer, if that makes sense. So like, what I mean by that is when I'm processing, suppose I get to the end of this buffer because the PGN I'm looking at is, 2050 bytes long instead of 2048. I can't do that here. So is there a limit on how big a tag name can be? Would be my next question. There's a line length limit of 255. Okay, well, what if let's think about this differently. Hold on. So let's say we do this. We don't have process tags anymore. We have an open pair. Okay, so let's stop. No, I don't have a choice. I have to do it this way. It makes it way more complicated to like think about in my head, but it's significantly, like, undeniably just faster by an insane amount to do it this way. So it's worth the extra thinking time, but it makes it more complicated. Like, this is complicated. This is a lot of code that just says, like, so this is like 157 lines of code to just say find an open bracket or the number 1 and go until you find the end of the game. But when you're doing it 1 byte at a time and you're keeping track of all this stuff, it becomes a lot harder when you can't really see too far ahead and too far back, which is why in the Finder we have the back buffer, so you can kind of go back and see what was behind you, because you need to know what was behind you if you want to go through it fast. So we also need to prep for the end of game stuff here too. Except there's no way to tell how far back you're going to have to back buffer is the thing. So let's try an approach like this. Let's assume we have to do a tag section until proven otherwise, okay? So if tag section if we're in the tag section, we'll handle it this way. And if move section, we'll do something else. So we'll say move list because I think that's what they call it in the docs. Let me just double check. What do you guys call this? Move text. So let's say move text equals false. So in the beginning, we're going to just blanketly assume that there's going to be a tag, and then we're going to look for it. So if tag section, and we might need a total bytes read. We might need that text, and we're going to rename this to tag pair section. There we go. That's what I want. Move text section. And then we're going to do a long. No, we don't need a long. It's going to be an int. Let's not make that assumption. Total bytes read equals 0. And here we can say if total bytes read equals 1. Oh, I don't want to do that every time though. I want to check that every time. You know what we could do though? We could do that. We could do that where? Where can we do that in a way that's not gonna suck? We could do it in the while loop phase, and then we're only doing it every 2 kilobytes, which could only be once. And we could say if total bytes read is 0. And we can say if buffer 0 not equal PGN constants open tag pair. So if the first byte we read or have, because we haven't looped over them yet, then we're going to say tag pair section is false. So this will minimize the amount of times we actually have to do this check significantly. And for the most part, that should be fine. Okay. Okay, so this is I think good. Because now this enables us to do this. Got open tag pair break case bgn constants turn case case and constants dot close. What else do we got? I think for now, let's just stick to these three. So then we can say okay. Now down here we can say boolean tag found move found. Okay. Tag found equals true. And then tag found equals false. And this would be move found equals true, and I don't know what sets that false yet. Maybe nothing. And I think this probably bumps here. Okay. And then and then now we can do, let's see how gross this gets. So if tag found so here we can do right. Guess let's hold, say, we'll clean this up in a bit, but tag label start, tag label end, tag value start, tag value end. We're going to need some of this. So this is going to be tag start label start equals total bytes read, and that's okay. Oh, these have to be longs. Shit. Alt shift. What did I just do? Okay. One of these days, I'm going to sit down and learn these motions like I promised I would. It's just, when's it going to get too annoying, you know? Because like right now I can still kind of function, but like the second this becomes like actually difficult, it's not going to be good. This is all, that one's pretty annoying. Okay. Oh shoot, I can't do that here. Then now I'm going to say if tag found true then I know my start's been found. Here I can say God, we're gonna have a ton of booleans for a little while. If current byte equals space, then tag label end equals bytes, total bytes, red -1. Not in here. Okay. That. Okay. And then I don't like this, but tag value started equals false. And now down here we say if current byte equals that, which in here we'll put that right here. Oh shoot. There. That. And we'll say quote. Boop. Okay. And that. So if I find one of those, then I would say if tag value started, it would be tag value end equals total bytes read -1. Actually, these are going to be -2s because it's a count, so we have to go -1 to 0 index it, and then minus another one to go back. And then here we say tag value start equals total bytes read -1. Wait. No, it's just that, because we're already one ahead. Open tag pair. Actually, we can do this differently. We can say, can do that. So if total bytes read equals 0, so tag pair section found. And then we come here, we set the current byte. We increase the number of bytes that we've read to 1. And then we say if I found an open pair, set the tag found to true, jump ahead 1. And then when I get to here, if I found a tag, is the current byte a space? If the current byte is a space, I have to -1 to get myself back to index 0, and I have to go back 1. And then if the current byte is a quote, and the tag value has been started, I have to lop off the end, and if it has not been started, then I need to come down here and say tag value started equals true, and then do that. Okay. So I think we need so tag value started, tag value ended, and I think we're gonna need tag, or wait, I can look at those instead. I don't need these, okay. I think we can say tag label start greater than -1. We don't need this. And then we can say tag value start greater than -1. And then here we can say tag label start. We'll reset here. Tag label end equals -1. Tag value start. This kind of works. And then tag value end. Oops. There we go. We'll set all that up. Anytime we hit the close tag, we'll deal with moves in a little bit. So if yeah, we're going to have to refactor this for sure. I already see some pretty big shortcomings. But Are we using this anywhere now? We're not. So that's not even needed. So, got this byte array. We're reading in 2 kilobytes at a time into this buffer. We're looping over them 1 byte at a time, counting it as we go. And we say, if I've found an open pair, set the start of this label. If I find a close, do all that crap. And if the label start is greater than -1, then we can come into here and say, okay, we're working on a tag of some kind. If I found a space that has to denote the end of my label, if I find a quote and I have a starting value, I know I'm on my ending value, or the ending value is 1 back after you derefer or after you get to base 0. That's why -2 instead of -1. Otherwise, use that. So that means that when I get to the end, we'll just put it here for now. We'll say if tag label start greater than -1 and tag label end greater than -1. Again, we will come back and fix all this. This is gross, but tag value start greater than. So we'll just make sure that we have everything, right? Tag value end greater than -1. So if I have all that, why don't I do something with it? So we could say tag pairs dot put new oh boy, is this a copy arrays kind of thing? Okay, that'll actually work. So we can do 1, 2, 3, 4, 5. Okay, so that's a length. So we would do start position. Okay, so we are going to do new string buffer dart or tag label start and then tag label end minus tag label start. How's that look? So constructor match for byte long long. Ah! I mean, I should be able to handle ints here. That should be fine. It's one game. There's no way that one PGN file is going to get that big, and that's, I think, an end I'm willing to support. So whatever. So let's do... I just want to see them. So we're going to do it this way for now. Just because I want to be able to sys these out real quick. We'll do string s2 equals new string buffer tag value start, and then tag value end minus tag value end, or start rather. Can't spell. And then this becomes S1, S2. Okay. We're also going to SY, so S1 plus. Okay. Now the tag section itself should definitely be within the first bufferable 2K, okay? It has to come before the move text, so it's got to be there. I can't really miss on that, which is good. Like there's no real way to miss on that. So let's put it together. I need a byte array input stream. So let's do that then. We've got unit tests for this now. We don't need any of this. We can clean this up a little bit. So let's come in here and say game bound. So we'll do a list here, list of game bound. GB equals that. So that's fine. Path 2 is the big one. We're just going to start with one game now. We're not going to do a whole bunch. Game with tags. I'll bring in that list. And then next here we're gonna say for game bound in GB. Which means new, or why, how are we gonna do this? Let's see, let's do pgn importer equals new pgn importer, and then we'll say import games. Wait, what? Oh, yeah, that's not what we want. Yeah, PGM parser is what we want.
I love the power of love.
PGN parser. Okay, and it wants the byte array input stream right away. Got it. Okay, fair enough. PGN parser. We can do it this way too. We can just do new PGN parser. We can just do it this way. And then new byte array input stream. And we're gonna have to change the way we did this. That's gonna have to come out now. It's okay, it can go here. Buffered input stream I'm getting a call from probably spam. Let me just, yeah, it was spam. So that's gonna go in here. Or no, that's gonna go here.
I love the power of love.
And then we're gonna have to do reset. What's a reset do? I think it's just going to bring me back to the start, if I remember correctly. And then we're going to say... Can I read between? Read and byte. Array with data is read into. Hold on. Okay, it's gonna take a byte array. Let me look at the docs for that. Hold on. Byte array input stream.
I love the power of love. It's so vivid.
Okay, this is what we want. Okay. Dot. Read all bytes. This sucks for this, but it's going to be fine later. And then we're going to do g dot get start of game for the offset. And then g dot get end of game minus g dot get start of game. And those are longs. Right. Because the thing is so large. Okay. So then let's back up. So now we can say, so we reset that, we can say how does skip work? Number of bytes to be skipped. So we can say skip g dot get start, skip that many, right? And we're gonna have to reset it every time too. So we're gonna have to do BIS reset. Means we don't need that. So we skip to there and then we say read Oh shoot, we can do this. Okay, okay. We can do this. We can do an array here, and then here we can read into that array. It sucks that I kind of need longs and I don't like them. What's going on here? Oh shoot, no! We're over here. I went to a went to a browser and came back. So that's kind of shitty. We can do it with what? How do we want to do this? So my problem right now is that my shit is so big that I need to use longs everywhere. And everywhere wants an int. And I can't just cast it. Because truncation. So how do I want to... I mean, I could just read one byte at a time. It doesn't really matter. This is just to test something. But like... I don't like that. Oh, stop it, Automod. Automod's being a jerk. Got a special message for Automod. We'll go,
Oh, hi, thanks for checking in. I'm still a piece of garbage.
That's what happens when you leave Automod on. So the thing we're doing here, because these chess game, or not chess games, but these chess files can get like multiple gigabytes in length, like it's not ridiculous to assume that they're gonna have to like read in like a 12 gigabyte file. And let's see. How big of a file until I need a long to track it? So yeah, once you hit like the 2 gigabyte mark, you kind of have to start using a long. Because you're going to go over the max size of an int. There are tons of PGN databases that are more than 2 gigs. So I can't use ints. But all of the byte array and buffered input streams, they all want to do shit with integers. Which really sucks, because when you're going through with the buffered input, like you can't just... Unless you want to like constantly be writing to like a string builder, you can't really do it. Oh yeah, there's I haven't even made a Git repo for this yet because I'm not sure if I'm going to continue. Anytime someone asks me a question that I kind of have to draw, we jump over to crap. We start drawing stuff. And yeah, there's a junk folder. This was the first iteration of this. The first iteration we had, or sorry, this one's actually the first iteration. Then I stopped using the naming convention and dropped the 1 instead of adding a 2. But this was all using strings, and this could parse about 250,000. I say parse. What I mean by parse is identify certain parts of the chess game. It wasn't doing anything functional. It was just identifying pieces to use later. But it was able to do 250,000 games in a little over a second. And then we did this one, and this got us a little under a second. And now in this one here, or this game finder, this finds the upper and lower bounds of a game. This can do it in like 0.2 seconds. So for 250,000 games. So that's good. That's great. But it's making it hell to find the games now. So I'm trying to figure out now, how can I use like, how can I split? Pretty good. It's been pretty quiet. We've only kind of just started doing programming streams. The channel's mostly been gaming up to this point, but I've been a developer for a while now, and I have some projects I want to do, but I'm having trouble like finding the time to stream other stuff and do the programming stuff that I want to do. So I was like, screw it, we'll just do them both at the same time. So we're kind of learning how we want stuff to look on the stream, figuring out where things go in terms of scenes and how they're going to be put together. How's your day going? So we want to split up a buffered input stream. Oh yeah, which distro are you going to now? I used to distro hop all the time, but I don't have any tinker time anymore, so I kind of just like, if I want to game consistently, like just no matter what, I kind of just have to be at the mercy of Windows, which kind of sucks big time. Nice. I considered trying to learn Rust for this, but I don't know, maybe I'm getting old, but I don't have the time to sink into it. I might rewrite this in Rust after I figure out the rest of this shit. I might rewrite it in Rust, but figuring out how I want to do all this parsing and how I want to set it up and designing the Postgres database, all that other stuff, I can't do that and learn Rust. It's just too much. NixOS sounds cool to me, but I don't know that I have any of the use cases that make it cool to really run with it. To read. So, am I crazy? I might be crazy. Yeah, that's fair. It does definitely help you automate like setup and recovery. I think the world we're in right now is a disgusting world. Oh no. Okay. Okay. Can we... Oh, get out of here, viewbots. We've got a special patented message for viewbots. It goes... oh, we'll stop the music really quick. Every time we get a viewbot, we have to say... It's the rules. Yeah, we are in a disgusting world where we're using byte arrays instead of strings because it's faster. So, okay. We're going to do the gross thing. Can I open a byte array input stream from a string input? I mean, that too. But this is also pretty gross. A lot of this is pretty gross. Let's see. I can do get bytes. Who cares? So let's This part doesn't have to be performant. You know what? We can use an int here. I know the file that I'm processing right now is not that big. Let's say that's a bad way to do that. Let's not do that. Let's do in bytes. Read. How big it will just do. Okay, we're definitely not doing this in a while true because that's going to be bad. Let's do screw it, 1,000. That's more than enough for this test. We'll do 1,000 bytes at a time. Okay. So we're going to read that. Oh, shoot. Okay. I'll go copy this from over here. Wait, that. Oh, yeah, the brackets. It doesn't like it without the brackets. Yes, mine as well. Where are we missing a bracket here? What have I done? My brain is not working today. We'll just copy it. Okay. And that's this read B. Okay, it really doesn't like that. Sure. It doesn't have to be oh, we need one more. One more. Boop. There we go. Finally got it. Okay. So now that we've read in 1,000 of them, we're going to do a new byte array input stream using that. You know what? We're being stupid. We're being so stupid right now. We don't need to do any of this. We don't need to do any of this. We're just trying to run a quick test. We don't need it. We want it. We don't need it though. We can just do this. We could just go look at the test that we made. 796. So offset and length is like that. We should be able to do just that. And now we'll do our parser. Okay. So that byte array input stream, we can get rid of that. And that. And read all bytes. Oh, you know what? Even better. Let's just do that. Done. We know we want to, in this particular case, we know we want to give it the whole file. What? Byte array inputs buffered. Oh, it shouldn't be find games, that's why. Okay. We're not using the finder, we need the parser. So we can get rid of that. Yes, exactly. So new EGN parser. Okay. Don't need the reset. That. Got the read. We don't need bytes and buffer. See, we didn't need any of that. Let's see if this even works. Close. We got some of it. Some of it worked. Okay. So this was our first attempt here. Let's take a peek. Oh, okay. Let me just check the time here. Make sure no one's trying to get a hold of me. Okay, so what did we notice here? That one was wrong. That one was wrong. Let me look at that game data too. Close some of these guys off. So we need to not parse spaces sometimes. Right. So this is going to be weird. So then go back. I think we find a quote. This is also going to get gross because we're going to have to do this silly buffer back buffer stuff. But we can worry about that later. We'll just inch forward slowly, one issue at a time until we get to that. So now we've got this quote scenario where we could end up with just two quotes side by side like this with nothing in it, which also sucks. But if we find a quote and the tag start has not started, or it is started, sorry, it's greater than. I just want to see what happens with the stuff I already did. What? Okay. But we never get to here. Okay. So that means it's greater than 1 and tag label end equals. So if the start exists and the end doesn't, if I'm on a space, I think that's right. We hit that. Okay. So we need no, this is what we need. We need tag label start equals -1. Because that means if the tag label start is -1, that means we haven't started doing that yet. Or the tag value start, not tag label start, tag value start. Because that value start, okay, so current value equals n minus 2. So let's shout some of this out here so that we can take a look. Or, you know, we can just, who cares? Just do this. Okay. I don't think 32... Where's my code page? 32 is a space. So we're on a... Yeah, right. We're on a space because we were a second ago. And the end is 5. And we've got a -1 in there. So that should jump over. Okay. And then 34 is a quotation mark. And when we get here, this is true, but it's not that. This is a quote. This is -1. So then we're going to set that here. We got 1, 2, 3, 4 that all have to be greater than -1, and we should have 3 of them. We do have 3 of them. And that one's still -1, so we can't do any of that. Now we're going to come into here. And we're going to keep jumping. We need to get to 34 again. 98, 117, 114, 103, 104, 32. hold on. 32 is space. Yeah, we're still looking for 34. Um, 12. Okay, here's 34. Why? Current byte 34? Current byte 34. Tag value start greater than -1. So why tag value N5? Tag value, wait, that's not. Okay, we've got issues. This is borked. Okay. That's fine. We'll look at it again. So, when I find one of these, the next character is what I care about. So, when I'm parsing, I can immediately set this to jump ahead to 1. So index 0, index... Okay, so... Can I put one here? Let's just jump. Right, so that should be 1. Now I want to see us get to here. And that's 5. So 0, 1, 2, 3, 4, 5. Right. So that part's fine. And then next, we're going to look for that quote. Which 32, I think, is that 34? I can't remember. Yeah, 34 is quotation. 32 is space. So we've got, and quote is also 34 here. So 34. We can get, wait, what? Wow. That just fell through entirely. Okay. Okay. Back up. Okay. And byte 69. Right, so that's event. That's the letter E. You know what? Let's do that so we know that we get into it. That's the end, because we found the space. So now we're going to step into here. Okay. That's just not a quote, so that's fine. Okay, so this is a quote. This is 34. So what happens here? I look at my current byte. That was a step into. So we get to here. This is tag label start is greater. And value is minus. Oh no. That's a problem. A little bit. But we're gonna jump this anyway. We should fall in here. Okay. Okay. Wait. Okay. So that should be 8. It is 8. So we're going to put this here. I is 9. Where do I expect to have to come back to this? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21. Okay. Okay. Here's the quote. Okay, tag label start is greater, and that's not equal to that, so we're going to jump that. Oh. Oh! Okay. That's not what we meant here. Okay, and then here we should be if tag label start is equal to -1, you okay, so we got to do this as if tag value start greater than -1. Try that. See what that gives us. Okay, hold on. I don't want to stop. I just want to see what happens. Yeah. So okay, and then this becomes, I think we might just be tired and guessing. That's a thing. We could just be tired and guessing at this point. Okay. If the label start is, if the label started and the value isn't started, look for a space. Find the space, set your end label tag. This won't work because I can never set that. And then if current byte is equal to quote, it really doesn't matter why. Oh no, it does matter why. So if we get this, this has to come out. So if we find a quote, we have to ask ourselves, I think this is what we started with, though. I'm certain this is what we started with. Sure, why not? Okay, getting closer. PNG parser 68. What? Okay, we're doing something wrong as well. Closer though. We got in here. So when I find it here, it should equal that because I want it to be one ahead of that. I want it to be one ahead of the square bracket. And then when I find the space, I want it gets all the way down to result before it happens though, so it's at the end. Oh right, because I bet this might work. No, huh? We still go over. Interesting. Oh right, that was a different problem. Okay, so we're not resetting then? Is that it? When we get that, we could be on a quote. We shouldn't be. I think we're pretty close to the end though, guys. This is going to need a ton of cleanup and a ton of thinking, but we got further. We got further. So read 2 kilobytes at a time. And then loop through them 1 byte at a time. Let's stop using this. Let's use I instead. Because I want to go back one when I find the quote. Same issue. Interesting. Range 165. Oh, we might have to do that. No, it still doesn't like it. Well, let's do this. Bang. So let's see, what do we get? We're looking for tag label start. Oh, okay, wait. The offset. The index of the first byte to decode, and then the length. Okay, so we got silly here. Let's get back to here. So start. So this would be start at offset 1. Maybe I need to just do, maybe I don't need to do the math. No, I gotta do the math though. Because it's not. Let's see. I see S1. No? There we go. So, oh, wait. Let's stop doing it this way. Label, tag, label, offset, tag, label, length. Get rid of that. Hey, look at that. Got it. Okay. Oops. Tag label or tag value. Offset. Tag value. Length. Okay. So wait, I do. That runs pretty fast. Okay. Now let's do the bigger file. Yee. Bleh. Okay, yeah, now we run into the buffer problems. I think I want to take this in a different direction. I don't like it. I don't like where we're going. I don't like it. I think I think we're probably going to end up taking a buffered input stream and reading it line by line. Because, like, let's see. Or is it a buffered? Can't read line in this, right? What can I do with a buffered reader? What do you take to make new an input stream, huh? Okay, we could say new input stream. Okay. I just want to see what happens if I do this. Okay. Actually, I think there's a has lines, isn't there, when you go this route? You can just do... That work? Okay. I just want to see what it does. I don't really care that much. I just want to do it. So this brings back a stream. Reads the line of a text. Or null. Okay, so BR read line. Okay. There we go. Okay, so while that, we're just going to... Let's just see if I can actually do that. I think that's fine, though. Yeah. Okay, so that's going to work. So, like... maybe that is the way to do it? Because, like, once you have that, you can just do S dot split on that. Zero dot, replace that with that, and then dot replace space with that, and then if we run that, we get the whole first side, right? But that's a lot of strings to make. Like, if we don't do that, and then just for funsies, let's put a return here. I think that's fine. Continue. Yeah, I know it's unreachable. I know. Fine. We do that. Like, see, that takes almost a second. That's not fast enough. I don't think. Can we split on first? So, like... split with delimiters. Splits this string around matches of given regular expressions. The bleeding? I don't know. We might do some looking at string stuff here. Starts with regex limit. Okay, so now splits the string around matches given the regular expression. So if limit is positive, then the pattern will be applied at most the limit number of times. The array's length will be no greater than 2x limit minus 1. Okay. So let's say split with delimiters. Regex is that, and we're only going to do it the first time. And that's going to give us a string array and then we can say system out the first one replaces that with that, which is nothing, dot trim plus the second one. Oops. The second one, which is going to replace that with nothing. None of them came out, huh? Or wait, we can do this just like this. We split it based on space. Replace that with nothing. And then we can trim that or not. Replace that for nothing. Dot trim. That's really gross. Love it. But what don't we like here? Expected semicolon. Really? Where? So far gone. I think that's really the problem. Yep. Index 1 out of bounds for length 1. There we go. Why? I don't understand how that limit works. The array returned in this method contains each substring of this string that is terminated by another substring that matches the given expression, or is terminated by the end of string. Each substring is immediately followed by the subsequence delimiter that matches the given expression, except for the last substring, which is not allowed to follow anything. So we get 2. That doesn't help. Yeah. What's split? I didn't know split could have a limit. Interesting. Limit 2 is interesting, but it still dies on the same thing. Oh, I guess it's dying on a new line, so that's probably fine. We can just... Oh, hold on. Okay, guys, this is where I'm going to leave it. I'm going to have to do some more thinking and research. Like, this is just looping through. I know what's going on now. It got to the empty line, and because the empty line is just a carriage return, it's dying there. That's fine. It did what I wanted. What I really wanted to show, though, is just like how easy the string replacement stuff is, but that's going to get like really bad performance-wise really quickly because of how many strings we have to make. So like, I'm kind of going to have to rethink what I'm doing here. I don't like the route this is going, and I don't like the other route. So yeah, I don't like how we were going, and I don't really like doing it the string way either. So I'm going to have to think about this more. I thought I had an idea when we first started here, but it's not as straightforward as I originally thought. So I think, like, I really don't know what I'm thinking. Maybe a string builder might be the answer here, unfortunately. I don't really like it. We might have to look into something else too. So, I mean, will this take a bite? It'll take a character. That's not the worst. That's not the worst. Yeah. We'll give it some we might be looking at a string builder here. Maybe. Hey, Clobber Stomp, we're just finishing up. How's it going though? I'm trying to figure out how efficient a string builder is. Before we take off though, I can show you what we did for the last few days. We've been working on this. There's a crazy piece of code that detects the first character and the last character of a PGN file, regardless of how many chess games are in it, but it does it ridiculously fast. So this piece of code here can actually process just that, finding the first and last character of 250,000 chess games in a fraction of a second. So I should be able to do this for millions of chess games in under a second. So what it does is it reads in 256 kilobytes at a time and then looks at every single byte individually. And all it does is it says, have I found the start of the game yet? If you haven't, look for that open square tag. And then also check to see if it's somebody's turn, because based on the specification, you don't need any of these for this to be a valid PGN file. Technically, this and this are just as valid. You don't have to provide any of them, technically. So we check to see what we've got, and then once we find the start of the game, we just don't give a shit until we find a new line character. Ignore everything unless it's a new line character or you've hit the end of the file. And then when you've done either of those things, you've either hit the end of the file or you find a new line character, then look backwards by 2 bytes. So when I get here, I look, nope, that's not right. All I'm looking for is either a 0, a 1, a 2, or an asterisk. But this is where it gets tricky. Do you remember that I said up here, we're only reading 256 kilobytes at a time? Well, what happens if your file's like multiple gigabytes and you have half of it in the buffer and you've already passed half of it? So every time you read 256 kilobytes, you also have to buffer the last 8 bytes just so you can go look at it in case you need to. Down here, we start to resolve that and we say, depending on where I am in the buffer, whether I'm in the first of the buffer or the second slot of the buffer, How large is a typical PGN? It depends how many games are in it. A single game is only 2 kilobytes. But if you download one of the reference database PGNs from the internet, it's 4 gigabytes or more usually. So it depends what you're talking about. I want this to be able to download like all of Magnus Carlsen's games and process it virtually as fast as if it's just one of your own. So yeah, exactly. So I want it to be able to process one game as fast as it can do close to, let's say, 200,000. I want it to feel about the same. And then once we get up over the million, then it's going to take a little bit of time, and that's fine. That's whatever. But depending on where we are in the buffer, so like if I'm on the very first, if I'm right here on the buffer, that means every byte that I need to compare against is in my loopback buffer, which is that last 8 bytes. And if I'm in the first position, so I've got 1 behind me because we're all 0 indexed here, right? So if I'm at 1, depending on if this was a return, because the way line feeds work, depending on if you're in, well, I don't know which operating systems are which, but Windows is a /r/n, which is 2 bytes. Not every operating system does that. Some of them are just 1 byte, so it's /r. So we kind of have to say, was there a return here? Yes or no, and then go back. But basically, once we've figured all that out, then we can say if I found a 0 or a 1 and the previous character is a dash, I've found the end of the game. If it's a 2 and the previous character is a /, I'm at the end of the game, or a star just ends it outright. So what that kind of looks like if we go through, we've got some test cases here. I've got a game with tags. That one works. I've got a game with no tags. That one works. We've got 2 games with no tags, 2 games with tags, and like variations where there's no tag at the front and tag at the front. The numbers we were working with earlier, I've wrecked this file now, so it won't do it, but we were getting like 0.2 seconds, I think. So if we do, 1 second, let's do this again. Buffered import. Okay, so let's call the PGN game finder equals new PGN game finder. Does that take it? Okay, do that. So now we do p.find games and then give it that. We'll just loop this forever. So we'll say while true. And then we're going to come down here. So we're just going to do this forever. And while we're doing this forever, we're going to capture the start and end times. So start and end. And this is going to tell us how many seconds it takes to process this file. So we'll just do this for now. We don't need any of this crap. So we've got this. What's the end game for this? Speed and parsing. So I want to be able to read PGNs or SKID database files or chess-based database files, and I want to be able to parse them into games that I can then use for position searches and game searches in a program that's faster and better than chess-based. It's a tall order, but I'm going to learn a lot about optimization because I know that we can do math ahead of time to make the position looking faster, and we don't have to save the search reference database in the same format as the annotation database, which also helps us save on speed. I think we can do way better. I think we can. Because I think that we can do better just by storing the data differently. So if we start this up, whoa, it's going fast, woo! So if we look at this, this is processing, this is finding the games, which is path 2, is that one. This is 1.43 times 10 to the negative 5 seconds. That's how quickly I can find every game in there. So if we do game bound, let's get the list of game bounds here and figure out how many games are actually in here. I believe it's a roughly 250,000. But let's get the exact count here. And down here we can say sysout games plus GB dot size. Games are 0, huh? That's not, were we not returning this? What are we doing here? It worked earlier. We had it earlier. Game indices. List. Interesting. We may have broken it. So it has to come later. First, we have to be able to parse the games. Then we have to be able to save the games. Then we have to be able to search the games. And then we can start talking about how to make it usable. But basically the idea that I've got is like a multiple database structure where things that you have annotated are not stored in the same place as things that you want to search. Like we'll say we have an efficient search and an inefficient search. If you want to search efficiently, you have to be searching on things, well, quite frankly, that compare well. So like you don't want to be searching a PGN ever. Instead, what you want to be doing is searching for calculated things. So like I can take any chess position and calculate it down to a hash, which is just a really long number, which is really easy to compare for a computer. And instead of saying things like, you know, if I want to find this position in every game in the database, well, there's a couple ways that I can do that quickly. First, I can just start checking every single row in the database for, you know, that fen string. Well, that would suck. If I've already calculated that fen out to a number, that's faster. But what's another way I can do that? Well, I can say, what's the point total of both white and black in this position? And I can say, bring back every position where the point matches. And then further refine that down and now say, compare based on my pre-computated number. And doing those two things in quick succession should bring me down from like 240 million rows down to like maybe 500,000. Just immediately, just based on the point value alone. You can also, depending on how we do it, we could say, okay, well, if there's also a change in the point value from one ply to the other, so between moves, we can also use that to cut down the amount of searching we have to do before we actually do the search. So I'm hoping that through doing math on all these chess positions ahead of time, I can really narrow down the search effort and really speed it up, because we've also got multiple cores that we can work with. So instead of being a single threaded application, I can send 2 cores out to the database and say, or threads rather, not cores, but send 2 threads out to the database and say, each of you bring back 2,000 rows and parse them as fast as humanly possible. Whoever's done first, go get the next 1,000. I can do that, you know, scalar. So as basically as many cores as you have, I can kick up threads. And I can just start destroying that database looking for what I'm looking for. But we're kind of going to have to do it like one step at a time. Exactly. We're building the database first. We're building the functionality first. Because if we can't do that, it doesn't matter how pretty it is. But the big thing is, if I can't beat ChessBase, I'm already willing to concede that and be okay. But we have to beat Skid, we have to beat En Croissant, and we have to beat the earnings that are free. Which I think is like just, that's going to be easy. I'd love to beat ChessBase, but if I can beat every other free thing, I'll be okay with that. It won't feel like a failure if I beat the other ones, considering Skid was made like 25, 30 years ago. So, yeah. In an ideal world, we will beat chess base. In the real world, if we can beat Skid, we'll be pretty good. If I do it, it'll be free. No matter whether I do it or whether I beat chess base or not, this will be free. And it will be open source. And if people want to donate money, great. Yeah, basically. That's why I really want to beat chess base, because it's going to be free no matter what. Like, even if it's 98% as fast as chess base and free, like, that's pretty much the end game, right? And there are already applications that can export or import from chess base. So that's kind of what I'm going for. Yeah, is like, I want to do the Lichess model. If you can donate, there's no website for it, so like, it's not like you're keeping it alive. It's just going to be a download on GitHub. But like, if you want to support it, great. If you don't and you just want to use it, that's fine too. But the good part about doing it this way, where it's going to be multifaceted, where it's like, we made the database part first, we made the PGN part here, we made this part here, is all those little pieces can also be used in other people's software to build on what we're making right now. So if all I end up with at the end of this is a mediocre product that is faster than Skid, so it ends up being faster than Skid overall, but the parsing is the only part that's really good. It can make really good files that other people can use. That's still a net win. Yeah, we're going to get there eventually for sure. Especially when it comes down to like types of searches, we're going to replicate whatever they have, and hope if there's any more that we can think of, we'll do more. If we make it web-based, it gets rough because it would have to be a subscription model, because we'd be using cloud processors to do all the work. But by making it local, there's no charge to run the service. So we'll see. We could try doing a web-based one, but you also run into storage issues, storing the databases. But it's not no, but we got to get the local version working first, I think, just so you can gauge it. You can link to local storage, but like, you can't have the database itself exist locally, is kind of the thing. Like, it works with a PGN file because you're just moving through a file. But once you get into a database that's indexed and you're doing multi-threaded hits to that database, the worker nodes are on the server and the file is local, so you can't hit it the same way. But there's definitely, like, an online version of this is not hard to do. Like, to implement, to make it is not hard. But I think the logistics of getting it paid for to make it as good as it is locally is hard. But writing it in Java, which is why we're doing it right now, that's kind of the thing. We could do cloud service engines, but like, it's also going to be able to plug into just Stockfish. So if you download Stockfish, you'll just be able to use it. You won't have to hit the cloud if you don't want to. It's all pretty destination agnostic. It doesn't really care where it runs. It could run on the cloud. It could run locally. It could use cloud engines. It could use local engines. It's all going to be abstracted. It's not really going to care where anything comes from. So it'll really just be the logistics around, does it cost me $100 every time someone turns it on? And I really think we can. Like, what's kind of silly is that, like, and I do have to go here in a second, but what's really silly is, like, if you look at the different versions of this that we wrote already, like this one here, when you work with strings, the cost is offloaded to the user if you charge. If you don't charge, that's where then it can't be free is the thing. So we'll see how that gets there. Keeping it free would cost. But when we're doing this with strings, this is the same thing that we were doing here, where this is ridiculously fast, which I'm going to have to look into what's going on here, but it's probably just me being stupid. This takes almost 2 seconds. Versus the, like, I had it running at 0.2 earlier, which I believe is correct. But yeah, I got to get going. I got to go pick up my daughter in a little bit, so I got to go do that. But this was fun. Nice to see you around, Clobber Stomp. We're going to be doing a lot more of these programming streams. We've still got D&D streams. We've still got gaming streams. So we're still doing all sorts of stuff. But yeah, we will be back. Talk to you later.